final project, distributed ledger technology in voter registration rolls. Selecting the project, focusing on record-keeping process that is being negatively impacted by the current structure. Current structures involving physical record keeping, centralized record keeping, that seems to be somewhere where DLT really shines. Voting processes are largely still paper ballots, paper records. Record keeping for registered voters is centralized behind the government officials in charge of keeping it up to date. And there's a lack of transparency that goes with that centralization. A lack of transparency can be a breeding ground for conspiracy theories and misinformation to take root. There is a decrease in trust over the voting process. The most recent presidential election polling by the Pew Research Center showed that Harris supporters overwhelmingly expressed confidence that people who are not qualified to vote will be prevented from doing so, while just 35% of Trump supporters are confident that non-citizens will be stopped from voting. So the party alignment is irrelevant. Any drop in trust should be addressed, since we want to maximize trust in the voting process. There has been a perceived increase in voter fraud, even though actual cases are very rare. The Heritage Foundation has a voter fraud database, which Camark had delved into themselves and found that the number of reported cases of fraud were much smaller, and the data that they were portraying was misleading, since out of tens of millions of votes cast or ballots completed, there were handfuls of cases of fraud. There's an increasing reliance on digital voting systems, and with that comes, there's a certain lack of knowledge among the general populace, but there needs to be a way to verify things. Distributed ledger technology seems like a perfectly suited solution to the voting process and the trend towards not only digitization of records, but the digitization of the actual ballots themselves. Is DLT the correct solution? I think so. It offers transparency, security, accessibility. The very architecture of blockchain allows for transparency in that all transactions are public. It's right now you have to dig around to find information regarding voter registration rolls, but whether or not somebody is an active voter or deceased or moved out of the jurisdiction, that's not something that is readily available, since it is centralized. It offers security. DLT makes transactions practically immutable and difficult to change. So the data that is being shown and is available to view can be trusted, and that's a huge issue with active voter registration rolls. Accessibility. Copies of the ledger are on each block, so if one block becomes compromised, there's still this exact same copy on other blocks that can be checked against. And even when something is being amended and just added to the blockchain, it has to be checked against other blocks to verify that this request for amendment is legitimate. So the structure I was thinking of consists of layer 1, the blockchain, layer 2, oracles, which will handle the requests by the clients and also verifying data according to what's on the current voter registration roll, versus for county 1 versus county 2, county 3, there can be an oracle for each county, and there can be in-state oracles may only talk with themselves. Interstate could talk with and work with other oracles to verify is this voter, are they registered under yours now, under your registration role, or not? They can verify the client, though, is actually a verified, authorized party to make the requests to change the role. And since it's not actually changing the role, it's adding to it. Anything that does get through will be there and be transparent. And of course, the client layer, which are the different counties throughout the United States. So the layer 1 is the blockchain with all the blocks. The voter registration rolls are on each block, and there's a copy of all of them on each block. So that solves accessibility and transparency. Layer 2, all the off-chain handling of data will take the user requests. It'll verify the users. If the users are verified, then the data needs to be verified. What is it are they asking to change? And if the new data is a legitimate voter that maybe has moved from one jurisdiction to another or has deceased, then the status of that voter can be updated and it will be sent to the blockchain for processing. So the oracles handle the bulk of the work, which offloads the work from the blockchain, and that increases the ability for scalability. We want as many jurisdictions to partake as possible. The clients are all the counties, because I believe the way it's set up, it's by county. Voting is by voting responsibilities, and the states handle elections, which are broken down into counties to handle what needs to be done. So they'll be the ones interacting with oracles, and those are ones with special keys, which would change as the official changes. And actually, in each transaction would have a unique key associated with it anyway, because of the inherent design. And only officials responsible for updating and maintaining voter registrations records are allowed. So challenges faced are the verification of the clients. We need to make sure that the people requesting information, or the entities requesting changes or amendments to the blockchain, are actually supposed to be allowed to do so. We also need to safeguard voter information. This will be handled by hashing algorithms. Very effective way of taking a subset of information and making it near impossible to figure out based on the hash key. Plus, we need to verify the voter information as well. We can't change anybody's for any reason. It has to be a legitimate change that needs to occur so that the voter registration roll is as accurate as possible. And scalability. We want as many jurisdictions, ideally all jurisdictions in the United States, to partake in this distributed ledger. That way the oracles can talk with each other and verify near instantaneously. Since the oracles will be handling the bulk of the processing of the data or the information requested to be added to the blockchain, that offloads the work from the blockchain itself, and that was a huge driver of scalability for Bitcoin, the layer 2 applications. So the problem with voter registration rolls were that the records were centralized, and this created a lack of transparency. And because of that lack of transparency, there developed a lack of trust. With our increased reliance on digital voting platforms like Dominion, there's a lack of understanding of how that all worked, which created an opportunity for malicious actors to take advantage. How does DLT solve the problem? Well, the centralized records are no longer centralized, they would be decentralized. A copy of all the records would be on each block. The information would be protected by hashing algorithms, so you could still have this transparency and the security. The lack of transparency is fixed because the transactions and any alterations to the voter rolls are public. Their lack of trust due to that lack of transparency, well, transparency grows trust. If they can easily see what's going on, then they're more likely to trust the system as it is. With the increased reliance on digital voting platforms, their DLT provides a means of securing digital aspects of the voting process. So we worry about people's information being too vulnerable. Well, hashing algorithms helps with that. Two-signature authorization helps with that. And verification, multiple levels of verification throughout the whole process creates a system of checks and balances that ensure that the data being submitted is legitimate, is purposeful, and accurate. For the lack of understanding, well, DLT would restore trust in the system, minimizing the potential for abuse or misinformation. Thank you.